So I had trouble with problem 3 on the physics test, which goes, electrons are being fired at the Starship Enterprise by a Romulan spaceship. Data calculates the velocity of the electrons to be that value, where c is the speed of light. What is the magnitude of the momentum for one of these electrons? So I started with P is equal to lambda mv, and that is equal to mv over square root of 1 minus magnitude of v squared over c squared, because lambda is equal to this, 1 over this. And so I wanted to calculate the magnitude of the velocity first, because all they give you is the vector. And to do that, you get the square root of all the components, squared, which equals 0.9434, and I kept the c. Now, I plugged that back into the equation, and this time the question asked for the magnitude of the momentum, so I'm going to get the magnitude and make this velocity the magnitude as well. 1 minus magnitude of v over c squared, And then plugging everything in, and we know the mass of the electron because it's on the formula chart. Square root of 1 minus 4c squared over c squared. And then you will result with around 2.6 times 10 to the negative 30. And then you have to multiply that to the speed of light, which is that, and the unit kgm over s. So when you multiply that, you'll get the answer, which is P equals 7.68 times 10 to the negative 22. Units. Now, the second part was a lot more confusing. Nope, that's a mess up. Because I didn't realize that the final momentum would be the negative of the initial momentum. In this equation, the beam is reflected back, which means the direction is opposite. As I said before, the final momentum is the negative of the initial momentum. And what that does is, in the equation, momentum equation of F net times change of t, and we know that change of p is minus initial, final minus initial, times, of course. So, because we know that final momentum is the negative of initial momentum, we can substitute this into here. We get negative pi minus pi is equal to F net t. And thus, we get negative 2 pi is equal to F net t. So, if we want to calculate force, because that's what the problem asks us to do, you want negative pi over square root, or not square root, sorry, the delta t. So, because t is 2, that gets crossed off, and you just have negative pi is F net. Yeah, really easy. So you go back to that equation that you had in the beginning. Oops, sorry, I already plugged it in. mv over square root of 1 minus now that we want the vector, we're going to keep b as a vector on the top. Over square root of 1 minus 0.9342. And that will give us p, remember, is 6.5. Sorry. Oops, not 5, 4. 8, e negative 22. 22. Sorry, it's hard doing this with one hand. 4.065 e to negative 22 and 0 newtons. I got run into this. And here we said that the force is going to be the negative version, so we're going to change each of these vectors to negative. Negative equals the force net, which equals, and this is your final answer. Zero newtons. Yay! So I finally get the problem. And it may not have been the best explanation, but I hope you got it. Thank you.